Hey guys, this is the screencast for section 6.5. So we've learned how to add and subtract matrices. Today we're going to learn how to multiply them. And this is a whole other ball game, right? All right. So first and foremost, when can we multiply matrices? To multiply a matrix A by a matrix B, what needs to happen is the columns of A must be equal to the rows of B. Then you can multiply them, and it'll also give you a way to figure out how the product matrix will look. All right, so let's just take an example. Suppose you have a matrix A, and it's got dimensions 3 by 2. And you've got a matrix B, and it's got dimensions 2 by 4. So remember, 3 by 2, that's rows, columns. 2 by 4, that's rows, columns. You put them, you kind of write them side by side. If these inner numbers are equal to each other, that means you can multiply them. And then the outer numbers will give you the dimensions of the new matrix. So this new matrix, after I multiply them, will look like 3 by 4. It's sort of like a chemical reaction. You have two elements combining, and then the product might look nothing like the products from which it came, right? You combine hydrogen, you combine oxygen, you get water that looks nothing like hydrogen or oxygen, right? Okay. Now let's first start by, just practicing, this, when can we multiply, what the dimensions will look like, and so on. So here it says to determine whether it is possible to multiply the matrices, and then state the dimensions of the product. Okay, so this first matrix is a 1, 2, 3 by 2. The second matrix is a 1, 2 by 4. You can multiply these because these are the same, so yes, you can multiply them. And then the product will be a 3 by 4. And what does a 3 by 4 look like? You're going to have 3 rows with 4 columns. And that's what the product will look like. Okay, what about this next one? I have a 2 by 3 and I have a 2 by 2. Because these are not the same, I cannot multiply them. Now, the most important thing you have to learn is matrices are not like numbers. Matrix multiplication is not commutative. So A times B is not the same as B times A, right? With numbers, whether you do 3 times 5 or 5 times 3, it doesn't matter. But with matrices, if you do AB and if you do BA, you do not get the same matrix. Okay, so it's very, very important. Order is very, very important. Okay, so let's multiply one time with this method that I've chosen here. So I came up with this. Don't let this scare you. I came up with this a couple of years ago, and I've just dedicated a full page to multiplying this matrix once. They're not always going to take you this much time, but I find it's important that the first time we go through it very, very carefully. Okay, so don't let this page scare you. Like it's gonna be okay. All right. So first, we're gonna multiply matrix A, matrix B, find AB. We're gonna determine the dimensions of AB first, right? So here I have a 2 by 3, and I have a 3 by 2, right? Because these are the same, I can multiply them, and then the product matrix is gonna be a 2 by 2. So when I multiply these two, I'm going to get a matrix that looks like this. Okay? Now, what we're going to do is we're going to go through this product matrix and we're going to start populating each of these spaces one by one, right? So what you kind of have to do is you have to think, okay, which space am I going to populate first? And suppose we're going to start with this one. Okay, what position is that in the matrix? This is row 1, column 1. So first you start with that. First you say, okay, I'm going to populate row 1, column 1. Then you go back and you start multiplying. Okay? So let's go to step 2 here. We're going to start with the first element, row 1, column 1. So we're going to start with this element right here, and we're going to populate this field, row 1, column 1. Okay, because this is row 1, column 1, what I do is I go to my matrices and I take row 1 and column 1. It's got to be in this order, otherwise it doesn't work. Row 1 and column 1. Now, take a look at how many elements are inside row 1. 1, 2, 3. How many are inside column 1? 1, 2, 3. Okay, it's supposed to be that way. Now what you do, you have to multiply each of the corresponding numbers and add the results. Okay, what do I mean by that? In row 1, column 1, I multiply the first number with the first number plus the second number with the second number plus the third number with the third number. Okay? So that's what goes in row 1, column 1. Okay, next. Move on to the next element. Now we're going to do row 1, column 2. Where is row 1, column 2? We're going to do this one. Row 1, column 2. Stick with me for a minute. So this is row 1, column 2. For that, I take row 1 and column 2. Okay? And then I'm going to take corresponding matrices, corresponding elements. First one with the first one. 2 times negative 4. Plus second one, negative 3 times 1. Plus last one, 1 times negative 2. You're probably asking, wait, aren't you going to simplify these? I am, but later. I couldn't find a more efficient way to do it. Okay? All right, let's move on to the next element. We've got 2 to go. Move on to the next element. Now we're going to do row 2, column 1. We're going to do this one. This is row 2, column 1. So I always do that. I underline the space that I'm going to populate, and I ask myself, what position is this? Oh, it's row 2, column 1. That means I need to take row 2, column 1. And now I do the same thing. Multiply the first with the first. Always circle them, right? The second with the second. Oh, I was doing my little coordination here. The second with the second plus the third with the third. Okay, you're probably asking, wait, are we always going to add them? Yes, you're always going to add them. Why? We really don't care. Does it matter? It doesn't matter. Okay. Last but not least, this last space. What position is this? This is row 2, column 2. So I need to take row 2, column 2. And then, so the first with the first, the second with the second, the third with the third, and then now we're going to go and we're just going to add them all. Okay, so here I have negative 6 plus negative 15 plus 6. Altogether, that's negative 15. And then the next one, I have negative 8 plus negative 3 plus negative 2. All together, that's negative 13. Here I have negative 15 plus 0. Love it when we get zeros. Plus negative 12. That's negative 27. And last but not least, negative 20 plus 0 plus 4, negative 16. And that's the product. Okay? All right, let's do one more. Let's do one more, but we're not going to take this long for it now, okay? I'll show you how to do it more efficiently. All right, so can we multiply these? I have G, I have H. What's the dimension for G? 2 by 3. What's the dimension for H? 3 by 2. Do they multiply? They do multiply. What product are we going to get? A 2 by 2. Okay. I always like to, when I'm multiplying them, just rewrite them next to each other, side by side, so I can make sense of things, okay? Make sure you don't make any errors transferring them. All right, so the product here is going to be a 2 by 2, right? So I make myself a 2 by 2. So here's 1, 2, 1, 2. Allow some space because you're going to be, putting in like the addition and stuff, right? Okay, so first time it's row 1, column 1, right? So what I do is, you can circle them, row 1, column 1. And so what I'm going to do is first one with first one, 1 times 2. And you can either write it like this, or you can just say it in your head and say 1 times 2 is 2. Plus, second one, 3 times negative 2 is negative 6. Plus, 5 times 1 is 5. Next, move on to the next one over. Row 1, column 2. So for that, I take row 1 with column 2. First one with first one. 1 times 3 is 3. Plus 3 times negative 8 is negative 24. Plus 5 times 7 is 35. Oh, wait a minute. Was that a negative 5 the whole time? Did I just put in the wrong number when I said don't make mistakes when you're transcribing them? Oh my goodness, silly me. So that has to be a negative as well. Okay, next we're going to move down here. Let's erase these markings. All right, so we're going to move here. This is row 2, column 1. So I take row 2 and I take column 1. First one with first one, 4 times 2 is 8. Plus second one with second one, negative 2 times negative 2 is 4. 0 times 1 is 0. Last one, row 2, column 2, row 2, column 2. First one with first one, 4 times 3 is 12. Negative 2 times negative 8 is positive 16. 0 times 7 is 0. And so I get negative 9, negative 56, positive 12, and 28. Okay. Now let's do HG, right? That's the reverse, HG. For that one, let's just write it like this. 2, 3, negative 2, negative 8, 1, 7, 1, 3, negative 5, 4, negative 2, and 0. Okay, so this one is a 3 by 2. This one is a 3 by 3. A 2 by 3, sorry. So what's the product going to be? a 3 by 3. That's a huge matrix. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So here, for this one, all right, let's do this. Row 1, column 1. Row 1, column 1. So always check how many in row 1, 2. How many in column 1, 2. Okay? First one with the first one, 2 times 1 is 2. Plus 3 times 4 is 12. Next, row 1, column 2. 2 times 3, first one times the first one, 6. First one times the second one times the second one, negative 6. Okay. Lastly, row 1, column 3. 2 times negative 5 plus 3 times 0 is that one. Okay. Now let's move on to row 2. Lost the 0. Okay, so here, row 2, column 1, row 2, column 1. First times the first is negative 2, plus second times the second is negative 32. All right, another way you can do it if you don't want to keep doing these circles is this next one is row 2, column 2. So what I do is, row 2, column 2. So now I have first one with the first one, 2 times negative 3. Negative 2 times 3 is negative 6. Plus, second with the second is positive 16. All right, last but not least, I have row 2, column 3, row 2, column 3. Negative 2 times negative 5 is positive 10, plus negative 8 times 0 is 0. Last but not least, last row, I have row 3, column 1, row 3, column 1. 1 times 1 is 1, plus 7 times 4 is 28. Next, row 1, column 2. First times first is 1 times 3. Second times second is 7 times negative 2. That's negative 14. And then the last one, last row, last column, negative 5 plus 0. Adding all these up, I get 14, 0, negative 10, negative 34, 10, 10, 29, negative 11, negative 5, and there you have it. Okay, next one, find DE. So here I have a 2 by 3, and I have a 2 by 3. These two are not the same, so not possible. Okay, moving right along. All right, another one of our, real life examples here. Okay, you own 3 car rental locations and offer 3 choices for vehicles at each location. A sedan costs $80 a day, a minivan $100 a day, an SUV $125 a day. Okay, so you have the price for a sedan, a minivan, and an SUV. The chart below shows the number of each type of vehicle available at each location. So in location A, you have 7 sedans, 5 minivans, 2 SUVs. In location C, you only have 3 minivans, and so on. Okay? And of course, each of these cars is placed at the standard 6 feet apart from one another. So, customers aren't mingling. Okay. Write a matrix V for the number of each type of vehicle at each location. Then write a cost matrix C. Okay. So it says to write a matrix V for the number of each type of vehicle. So that we're going to get from here. So V is going to be each car at each location. So it's basically that matrix over there. 7, 6, 4, 5, 8, 3, 2, 6, 0. Then it says to write a cost matrix C. Okay. So here's how this will work, right? So this is a 3 by 3. But now look at what these stand for. So this is location A, location B, location C, and then this is the sedan, the minivan, and the SUV, right? C, you have the cost for the sedan, the minivan, and the SUV. Because in this one, those are like going horizontally, sedan, minivan, SUV. In the new C matrix, it has to be going vertical. So we have to do 80, 100, 125. Okay, so this is the cost for the sedan, the minivan, and the SUV. Okay, so those are the two matrices. Now, suppose somebody wanted to know, okay, suppose I rent all the cars in all the locations. How much money am I going to put in my pocket? So to figure this out, right, you're going to have to multiply these two matrices. Now you're thinking in your head, oh my God, Miss Malikan, that's so silly. I could just crunch a couple numbers and figure it out. Well, yeah, maybe you can, but you know what? Like, if you're, in charge of the finances for, let's say, Enterprise Rent-A-Car or Hertz, you don't just have 3 locations with 7 sedans and 5 minivans, right? You've got like a whole bunch of locations. And for that, you need not 2 by 2 matrices, not 4 by 4 matrices. I mean, we're talking about 20 by 30 matrices or whatever, right? So in that case, you're not going to be crunching numbers by hand. You need a legit way of doing things. Okay, so we want the total daily income, assuming that all cars are rented. So what we're going to do is we're going to multiply V, which is all the cars and all the locations, times the C matrix, which is the cost of each of them, right? So now we have 7, 5, 2, 6, 8, 6, 4, 3, 0, times 80, 100, and 125. Can we multiply these? Well, we actually can, because this was a 3 by 3, and since we made that a column matrix and not a row matrix, now it's a 3 by 1, right? So now these are the same. Otherwise, it would not have been. And so now, if I take a row and a column, oh my God, magically they have the same number of elements in each of them. Okay, so the product here is going to be a 3 by 1, right? So we're going to get a 3 by 1 matrix, 1, 2, 3, and 1 column. All right, so what we do is we take the first row with the first column, 7 times 80 plus 5 times 100 plus 2 times 125, that's 250. Then second row, first column, 6 times 80. That doesn't look like 6 times 80. plus 8 times 100 plus 6 times 125. Last but not least, this one, 4 times 80 plus 3 times 100 plus 0 times 125. Gotta love those zeros, man. So finally, the matrix, right? The matrix is 1,310, 2030, 620. What is this? What have we found? Well, if all cars are rented, location A will bring in $1,310 a day, location B, 2,030, and location C, 620. They really need some SUVs over there. Okay. What will be the daily income from all three locations if all cars are rented? So for that, you just want the combined 1310, 2030, 620, $3,960. That is a lot of toilet paper you can buy. Okay? All right. That's 6.4, everybody. Again, the homework will be due after we get back and discuss, and then it'll be due at 10 p.m. that day. All right.